Hello. Hi. Hope you had a good day with the break in between being longer than expected. I actually am glad that break was there because usually with a one-day conference, people don't get to talk to each other very much. By the time all the talks are done, you just get tired. So I was like, this is great. PGE helped us out here. So coming to the panel, I think the point of the panel was to try to bring out some questions around tooling and using that tooling from the creators and users of this tooling and get some questions answered that will make us build better tooling for the future as well. So there are 5 great people who were willing to be part of the panel, especially with the hard questions I'm going to ask. Let me quickly introduce each one of them. The first person is Rachel Thomas. Rachel is a fast.ai co-founder and the director of the USF Center for Applied Data Ethics, where she works on data ethics, AI, accessibility, and bias in machine learning. Welcome, Rachel. Hey. The second person is Clément Delanger. Clément is the CEO of Hugging Face, the company that built the library PyTorch Transformers, which is now called Transformers because they added TF2 support. And Clément also has a background in computer vision. He actually worked at a French startup called Moodstocks that eventually got acquired by Google. So welcome, Clément, to the stage. Thanks, Clément. The third person is Maria Popova. She is a PhD student at CMU at the Laboratory for Molecular Modeling. And she's also the author of OpenChem, a PyTorch-based deep learning toolkit for computational chemistry and drug research. Welcome, Maria. And next is Michaela Paganini. She's a postdoc at Facebook AI Research. She investigates the learning dynamics of neural networks. And she brings her physics background and scientific approach to machine learning research. And she was previously a physics PhD student at Yale and also part of the ATLAS project at CERN, where she was doing particle physics research. Welcome, Michaela. And the last person on the panel is Lisha Lee. Lisha founded Rosebud, which is a stealth startup, so she can't actually tell you what she's doing. But she can tell you that they're building tools for creators for photo and video generation. And Lisha was actually in the VC world before. She was an investor in several startups and did her PhD at UC Berkeley. Welcome, Lisha. Thanks all for being on the panel. I picked 5 of you because you are users of PyTorch and creators of things on PyTorch, and you have a combination of both, between education and library creation to core contributions and so on. And startup research to production, which is the theme of PyTorch these days. So I think I have a very simple opening question to set the theme, to set the context. What are the central tools and frameworks you guys rely on and take for granted and use them day to day? Start with Rachel.
Sure. So I would say Jupyter Notebooks is a key one. They're great for teaching, but they're also great for software development. At fast AI, we're moving all our development and testing into Jupyter Notebooks as well. And I think that they've been really revolutionary. Beyond that, I think kind of many of the obvious ones, PyTorch, of course. Yeah, we're a fan of Hugging Face transformers.
Thank you. Great.
Yeah, I mean, for us, surprisingly, even if we are a builder of a tool, we don't use so many tools company-wide. Everyone obviously have their favorite tools.
Okay.
We're big users of PyTorch, obviously. We released our NLP library on TF2 too, as you shaded me a little bit earlier. And it can sound kind of like a cliche, but we're spending our days and sometimes our nights on GitHub to manage all our open source. We end up a lot like I received like dozens of emails like asking me like, oh, can you add that? Can you solve this problem? And I have an auto reply at this point. Raise an issue in GitHub, open a pull request, because that's very much what we spend our time on. GitHub is our OS in a way. So even if it's cliche, I think that's an important tool not to forget.
Great. Maria?
Yeah, for us, we use Python and PyTorch for our research, and PyTorch is great for fast prototyping. And we also use a couple of commercial software for molecular modeling, because our lab is working on computational chemistry, and part of that is doing like real simulation. And yeah, we try to put all our code online, open source, to make it open source, and for that we use GitHub as well. So I would say those are the main software, main frameworks we're using.
Yeah, likewise, Python, PyTorch, of course, and other deep learning libraries. And then if I were to wear my scientist hat, I would say all of the scientific Python ecosystem, SciPy, Matplotlib, Pandas, etc. And then, again, as a high-energy physicist, I would say a lot of open source libraries that are domain-specific and that have been developed by software groups in the field, IRIS-HEP, HSF, etc. And then a lot of tools in C++ as well, because as a scientific community, we have to integrate with either old, archaic, or highly performant code bases. So there is that dimension as well.
So yeah, we use a suite of tools. I mean, obviously PyTorch. We also use TensorFlow. I think the thing with PyTorch is that I mean, we're trying to solve for adopting research into like fast prototyping. So not only do we have to write new architectures ourselves, but also like because the open source community offers so much, and PyTorch I think is very popular in the image generation literature and research area. I also run a distributed team, so Collab Notebooks, GitHub, totally a great stack for that. So me and my engineer, we sit different cities, different time zones, but having these tools that make it just basically, I think software is the most easily distributed thing that you can kind of run team-wise. And then this is like a more recent thing. We've also tried, for cost reasons, using Spot instances to like run training. So there's like a new tech blog post that we wrote about how to combine that with Kubernetes and Horvath on AWS.
Nice. I heard a lot of Python. I heard a lot of open source. I heard a lot of ecosystem / being able to use stuff from other people, especially Rachel said, hey, PyTorch transformers and so on. And then I heard from Maria about commercial software where thinks it might just be important. And I heard PyTorch, which is nice to hear. I have a simple question. I heard open source, Python / large ecosystem, commercial support, brand value. Which of these are the most important aspects? Like which of these that can you simply not give up? Like, is it open source? Is it the ecosystem, the network effects? Is it commercial support as a startup founder? Would you expect that it comes with certain support? Which of these? Maybe I will, because everyone looks like they are not sure what to answer. Yeah? You want?
Oh, go ahead.
I was going to say, I mean, we just want to use things that work. So I don't know that we feel strongly about a particular kind of whatever works. I mean, a tool that we use that's pretty uncool is Microsoft Excel is really useful, and we actually, have a convolution implemented in it to show people kind of how it works. It can be a great tool. So we do kind of use, I would say, like a range of tools, and it's just kind of finding whatever's best for the job we're trying to do.
Yeah, I mean, to complement that, what we're looking for when we're investing time onboarding ourselves or our team on a new tool is for it to be future-proof, right? To make sure that it's going to get better in the next few months, few years, that it's still going to be around. And so when you think about future-proof, then it doesn't really matter so much if it's open source or commercial, right? If you have an open source that is well-maintained, where you have like community behind it or organizations behind it, the same way PyTorch is, for example, it's as future-proof of like a service that you're buying from a company that you know will be around for some time. So I think future-proof is like the thing that you're looking at when you're thinking about adopting new tools.
Okay.
For us, I'd say the most important is whatever lets us do the fast prototyping thing to try ideas very quickly, because I mean, you don't want to spend a lot of time on trying the idea that won't work at all, right? As a research scientist. So I would say Python is great for that, and this is not something we would ever give up on. And also, we don't care that much about the open source or commercial, as long as the software does whatever we need it to do. So yeah, I would say that is the most important aspects for us.
I would echo both of the last opinions. The future-proof for experiment design is really important because we're building software for the next generation of experiments, and so software has to last. We can't just go off of fads or Twitter popularity. We need something that will be there years from now, and obviously, that oftentimes causes some delays in really trying to evaluate and assess whether the software will have a lifespan of half a decade or half a month in terms of the support. But that is key for scientists. And then again, the Python ecosystem allows you that speed of prototyping and iteration in terms of experimentation and research. So both dimensions are really important to us.
I think open source matters insofar as I'm providing a good environment to attract good talent. I mean, this really matters. But in terms of, I think, support, I think most of the frameworks now, hopefully we heard an announcement earlier today, but like there's a lot of good cloud infrastructure support. And right now I'm doing B2B, but when I was originally focused on a consumer deployment, I was experimenting so fast with the actual models that I couldn't have a serialized version to run on device, and so I had something that was deployed on cloud that I can constantly change. And so having a lot of good support for various frameworks, which PyTorch does, makes it easy to prototype and give it to my customers.
Okay, that's great. I heard some very practical answers. Whatever gets the job done. To, it's actually important for an ecosystem to be there. To, Clément's answer as well. So that's interesting. So now, I think one of the things that maybe we need to explore is how do you pay for tooling, right? Like, the economics of tooling itself. So I heard that I heard Excel being one thing,
And I should say we use it as a teaching tool, and there are things that are useful to do in it, but we're not, like the fast.ai library is not in Excel, obviously.
That would be an interesting fast.ai library. So I heard a talk recently that said something in the order of NumPy has like what, 1 or 2 full-time developers, and that's the funding they have, whereas NumPy is universally used. Whereas I presume if we have to buy something like Excel, we wouldn't really balk at buying it. We'd just be like, oh, it's like $50 or whatever. We'll just buy the license. So I think there is a bit of a systemic issue, and I'm wondering, I'm asking the panelists, like, what would be a way to fix this? Like, what are your thoughts about, like, the economics of tooling? Should we just make all tooling commercial, even if it's open source? Should we, like, how do we have the most popular tooling also be sustainable? Does anyone have thoughts here?
That's a good question. I feel like if you have the answer to that, you should start a company together tomorrow. I think there's like a big switch happening, and if you talk to investors today, I think Andreessen Horowitz released an article a few days ago, basically saying that the first stage was software eating the world, and now open source is eating software, where basically you have a new world where the boundaries between software and proprietary and commercial are fading in a way. You used to have this open source, which was mostly hobbyists, not in the bad sense of it, but people doing that on their spare time, or like very, very small teams. And you would have like commercial, and there wouldn't be kind of like ways to go from one to another. Now I think it's more complicated than that, and tools like PyTorch or transformers are testament to that, where you can really kind of like take advantage of what is great with open source, meaning that everyone collaborating to the same tool, the power of the community, the power of adoption, because people can use it the way they want to use it, rather than you telling them how to use it. But still build a company around it and find a sustainable way for you to keep building this tool and keep improving this tool. So I think the current evolutions are by themselves kind of like finding solutions to the problem that you talked about, which to me was more a problem of the previous world than the new world, where now you manage to find your models for open source. I mean, there are countless examples from Mongo, Elastic, Confluent, HashiCorp. Like you have now like tons of multi-billion-dollar companies that have been built around open source. So now is a good time if you want to do that, if you want to start a company around open source and kind of like make it a sustainable business. I think you can today.
Okay, so
I'd say, I think there are still serious gaps in that ecosystem, though. And so, like, one example is package management. Like, there's definitely kind of need for something better there, maybe with like continuous testing, where nobody has stepped in yet to kind of provide, or like, the solutions don't have enough kind of support.
yeah.
And I don't see kind of like an obvious or easy solution to that.
I mean, just quickly, I think I've seen there's a lot of capital that is willing to invest in popular open source teams that want to do a prosumer layer on top of those. So I don't think it's like a problem of funding. It's just, build something that people love. I mean, I'm saying obvious stuff here.
Okay.
I think definitely like public and private partnerships are another really good way to go. This hybrid model, I think, has worked in the past really well. If we think even just at Project Jupiter, not for profit, but with significant contributions from companies that lend some engineering capacity to the project in the form, again, of people sitting on the board and contributing real code, while obviously taking advantage of the technology in their technology stack in the company. As CERN as well, with CERN Open Lab, we have great corporate partnerships where, again, companies can collaborate with CERN to help develop our open source code, work on some laser-focused projects as well, and mostly provide, again, that engineering capacity to keep on developing in a sustainable way and giving back to the community in an open source way.
Yeah, I agree. A lot of commercial software, they offer academic licenses, so you can just access it for free if you're like doing the research, not for profit. That I think is a good model to be. But if you want to use something to actually like base your that will be used for your business, I think that's fair to pay for the software.
Okay. Fair enough. I think I heard interesting answers. I mean, Clement had a detailed answer because I presume your company has to think about transformers and how to sustain that. Um, I still have some deep questions about that because, well, what Lisha and Clement said are someone like NumPy could raise a Series A and then get a huge valuation and then figure out how to make money later. Okay, great. Those are very useful thoughts. Thank you. And I wanted to ask a question that is actually, beyond software tooling. We have educators, scientists, startup founders. What are the current things, you said some of the software you have, these are things that make you productive, these are very useful, helpful to advance your mission. What are current things, software or not, that are making your mission unproductive? Like what are the things that are generally not letting you progress? Do you have any like broad thoughts, but giving ideas out to people who might want to disrupt that space?
I mean, just like bouncing off the subject of tools, for us, what's really important is for tools to work together. So like, for example, when we released the TF2 version of our NLP library, what was really interesting and important for us is to give users the ability to basically go from PyTorch to TF2 for teams that have some people working in PyTorch and some other people working in TF2 to be able to collaborate, right? So it's sometimes frustrating with tools is when they don't work well together, when you don't have like the interoperability between them. And on the reverse, when they work well together, it's like a delight. Like for example, the fact that you can now train on TPUs with PyTorch, even if obviously it's two different companies that are sometimes kind of like conflicting in their goals. For us, it's like amazing because it means that you can start taking the best of both worlds and really make your workflow efficient and productive, whatever tool or framework or language you want to use.
Interoperability, basically.
Yeah. Yeah,
So
and the lack of it is
Yes.
sometimes a challenge.
So if your bank could talk to your taxes directly, you don't need
Yeah.
to do a bunch of work.
Yeah, that'd be great.
Yeah, I would say access and accessibility are still issues, even though we're making progress here. But when it comes to cost or energy consumption, those are still outstanding problems, I would say. And then in terms of tooling, I would say the proliferation of it. And with that, the lifespan issue that we mentioned earlier, will this tool be supported 2 months from now? Before I make the investment to integrate with it, I would want to know if the community will support it and if I will still be able to speak the same language as the majority of the people in the field moving forward. So those are key. Yeah, those are the main thoughts.
Nice.
I kind of said this last time, but package management is a pain point for us.
Package management.
Yeah, I would say the research reproducibility is an issue for us when we take a paper, get the code, and actually weren't able to reproduce the results for, like, this could be for many reasons, but that's a problem.
Great. I think we heard in the research track from papers with code who are trying to improve it, but
Yeah.
as a field, I guess we're trying to make a concerted effort to fix that. Just curious, how do you deal with that in something like chemistry, which it must be much more complicated, I presume?
Yeah, true. And also, I would say that something like culture in the community is slightly different from pure deep learning, machine learning, like statistic community. So people often don't care about sharing the environment, something like Docker, and you can just you take the code, and it's very hard to get the same results. And also. There are like different tracks in drug design. So people working on small molecule design, people working on retrosynthesis models. And if we want to build a whole automated pipeline for drug discovery, we need all these parts. And sometimes we take some results from other research groups, take their code to build a pipeline for our own process. And another issue could be is that like the best retrosynthetic model, they now they use Keras and Theano, and it's very hard to plug it into PyTorch pipeline. So this kind of they use very outdated software, and maybe they even have the better version, but for some reason they don't want to share that open source. They keep it to themselves.
I see. That used to be a bit of a problem in
Yeah.
the machine learning community too, and now it's like people who keep their code, I guess, just lose out in the long term.
Yeah, there's still a little bit the issue though. Like we're seeing it with the library. Like we have like dozens of thousands of people using it for like fine tuning, pre-training. Not all of them are sharing back the weights. Fortunately, a couple of people do. Like for example, with people sharing their weights for German and for Mandarin within the library, and I think it's awesome. But it's still kind of like the same way. There's like 1% of the people online that are actually actively contributing to something. It's still a little bit the same with deep learning, I feel like.
Yeah, that makes sense. I'm actually surprised, the majority of you being in the Bay Area, none of you said commute. So that's interesting, like reproducibility being at the center of advancing your mission. I think on probably the tooling topic as well, I wanted to talk a little bit about a question I asked something similar in the last year's panel as well, which is in machine learning, in the whole space, in the tooling space, the entire panel said PyTorch or TensorFlow. I mean, that's really about it. And the whole tooling has consolidated around these two things, which now look very much the same. So I'm just wondering what your thoughts are on about the upsides and downsides of this, and if you see any ways you want to use the upsides or address the downsides. Any thoughts on this aspect of non-diversity in the main tooling that's powering our field?
I will say at fast.ai we are definitely interested in the promise of Swift for TensorFlow as a potential tool down the road, and even included it in our last course. And we're still using PyTorch kind of fully in our library right now. So I don't know that it's like fully consolidated. And Swift for TensorFlow is not Python; it's a new language. So I feel like there is kind of still some openness about like there may be more options in a few years.
Okay, you're hopeful of the future.
Yeah, I think there's still possibility. Like it's not, yeah.
Great.
Yeah, I pretty much agree with that. We're super excited about like Switch for TensorFlow too, and we think there are also more and more kind of like verticalization of the tools. Obviously, transformers is a good example of that because you end up using significantly different kind of models and technique for every single field of machine learning. I think more and more you'll see vertical tools emerging that are going to be amazing for robotics, or like amazing for self-driving, or amazing for NLP. Just because at the end of the day, as deep learning is really kind of like replacing software 1.0 with different ways of building products, different ways of building startups, and that it's kind of like spreading to any single field. You'll need more specialized tools to really address every single field rather than just having one tool and using it for every single field.
I'd say our life would be easy if there was an unified ecosystem for research experimentation, because as I mentioned, this kind of relates to the reproducibility issue and building a single pipeline based on the results of other research groups. So if like someone shared their code, it is on TensorFlow, and I want to use this model in a combination with my model, which I develop everything on PyTorch, this sometimes becomes an issue. Yeah. So I would be happy if everyone used PyTorch.
Yeah, for me, for sure, the upside of consolidation is that we don't suffer from the JavaScript syndrome where there are hundreds of different ways of doing the same thing. And instead, as Maria said, like we have this opportunity to speak all the same language and build this ecosystem of tools around a agreed upon schema, which could be PyTorch or TensorFlow or others. The downside of that, though, I would say that if that doesn't fit your needs at the moment, then you basically have to resort to building some highly customized solution, and then you're no longer part of the in-group. So at that point, it's really hard for you to communicate your ideas and share them with the rest of the community because you're working on something that is very niche. And the other downside, I would say, is the potential explosion in size of these frameworks. So I don't know, I think one of the advantages of NumPy, for example, is that I can fit it all in my head. I know exactly everything that I can do with that, more or less. And there is a risk of, creating huge frameworks that are extremely complicated and only a few power users can really be productive with them. And then as the size grows, then the average user just becomes overwhelmed. So we need to be careful with that and maybe rely more on this ecosystem system to break out all the different various ancillary tools, Torch Vision, Torch Text. I think Torch has done a really good job so far at keeping things separated enough so that you can import only what you need and then branch out only if you need to.
Yeah, I think I've not had to make a choice between the two, and it's pretty, especially since now TensorFlow is looking a lot more like PyTorch, it makes it easier to write in as well. But given that we're we basically have an API for all of our trained models, and so if it's Dockerized, it runs in the same server. So any, whether it's PyTorch or TensorFlow, it can. It's really a matter of how can we get this thing up and running faster. And so if we're getting things from open source, then a lot of it, because the research community loves PyTorch, it's going to be in PyTorch. But then there's also really good models that are already written in TensorFlow, and so we can use it. So I haven't really been. I think the pros for me are, if it's fast prototyping, both frameworks are so well supported by cloud infrastructure that I've had no issue using both. And personally, have a little bit more preference for PyTorch, but whatever the open source community kind of loves.
What about you, Zoe? I feel like you're the best person to answer that as a creator of PyTorch and maintainer of it. How do you feel about this consolidation?
I am not on the panel. But because this is the last question, I'm happy to answer. I think it's really bad, personally. I think it basically kills innovation in a very deep way. So I would rather have competition, brutal competition, than being in a place where there's two frameworks who are comfortable with each other. So I think the panel was pretty interesting to me, at least, because I think I heard very unique perspectives, like funding open source, like with a VC model, or like various different things. Packaging. If someone can fix packaging, that would be saving the world in a lot of ways, especially me and Rachel. And Clément had very interesting thoughts about like the vertical integration, and I think that's something Maria and Clément and Michaela shared to an extent, which is I just want things to work in an interoperable way. Like it's not so much as like they're different tools, but hey, they're different tools. Maybe they do each of these things differently, but I wish they just talk to each other better, right? Like that's fundamentally what you guys were going for. Yeah, without further ado, we could thank the panelists for being here. And I believe the next thing is our incredible set of posters, but I might just be wrong. But Joe will probably come on stage and tell us what the next program is, and we could walk off stage.